Hi, my name is Matt Hosick, and I'm a postdoctoral researcher with the UCLA Galactic Center group. Today, we'll be talking about how we can see through the galaxy in order to observe stars at the Galactic Center. Our Milky Way galaxy is what is called a spiral galaxy. By looking at images of nearby spiral galaxies, we can get a pretty good idea of what our own Milky Way looks like. If we were to look at the Milky Way face on, we would see a galaxy with a bright region in the center, surrounded by large swirls of gas, dust, and stars. If we were to look at the Milky Way edge on, we would see that almost all the material in the galaxy lies along a flat disk, like a frisbee or a pancake. Here is an artist's rendition of the Milky Way galaxy. The sun lies in a spiral arm approximately 26,000 light years away from the galactic center. Because the galaxy is a flat disk and we're located within that disk, we need to see through these other spiral arms in order to see the galactic center. This is important because spiral arms contain large concentrations of gas and dust we call molecular clouds. Molecular clouds can come in a large range of shapes and sizes. They can contain anywhere from a few to a few million solar masses of material and can span sizes from tens to hundreds of light years across. Molecular clouds can appear cool and dark, like Barnard 68, shown here in the center of the slide, or they can serve as the birthplace of new stars, which heat up and light up the clouds to produce beautiful nebulae. For example, the Horsehead Nebula to the left, or M78 to the right. Molecular clouds block the light from background stars from reaching our telescopes, causing them to appear much dimmer than they would otherwise. We call this dimming effect extinction. You can see the effect of extinction in this image of a molecular cloud in the constellation Aquila. The dark regions only appear dark because the molecular cloud is blocking the light from the background stars from reaching the Earth. So, when we observe the galactic center, we need to see through all of this extinction. In fact, you can see the impact of extinction with your own eyes. If you look toward the galactic center on a dark night, you'll notice that the Milky Way looks like a faint stream of light with a giant dark streak in the middle. The faint stream is composed of the light from billions of stars of the galaxy blurring together. This is the pancake that makes up the majority of the galaxy. The dark streak, which is sometimes called the dust lane, contains the molecular clouds that block the light from the stars behind them from reaching the Earth. That is why this region appears dark. And you'll notice the galactic center is right along the dust lane. In fact, there is so much extinction between us and the galactic center that in optical light, that is light we can see with our eyes, stars appear 600 times fainter than they would otherwise. This makes the majority of stars at the galactic center too faint to observe even with the most powerful telescopes in the world. So, how can we see the galactic center at all? Well, we use a trick. Instead of observing the galactic center in optical light, we observe it in infrared light. So it turns out that objects can emit light across a wide range of energies, which we call the electromagnetic spectrum. Here is a diagram of the electromagnetic spectrum. Optical light, which is what we can see with our eyes, is only one small portion of the electromagnetic spectrum. However, you've probably come across light from other parts of the electromagnetic spectrum without even realizing it. For example, when you go to the doctor and receive X-rays, the doctor is taking an image of your body using X-ray light over here in order to see your bones. When you listen to a car radio, your radio antenna is receiving information from radio light, which is over here. So infrared light is just another part of the electromagnetic spectrum. This is useful because extinction from molecular clouds is far less strong in infrared light than it is in optical light. For example, here are two images of the same molecular cloud, Barnard 68. The image to the left is in optical light, while the image in the right is in infrared light. You'll notice that in optical light, the extinction is so high that it completely blocks out the light from background stars. However, if we look at the nebula in infrared light, there is far less extinction, and so we can see many of the background stars. Here's another example, this time with the Eagle Nebula. Again, the image to the left is in optical light, and you can barely see any stars in the background due to the high extinction. However, if you go to infrared light, like this image to the right, you can see many more stars in the background because there's much less extinction. So, how are we able to see through all the extinction in the galaxy in order to observe stars at the galactic center? By using infrared light. Thank you.